Hello all, my name is Chirag Patil and welcome back to my YouTube channel. So in previous video, we had learned about gradient descent and how it's work. So in today's video, we will understand what is the difference between gradient descent and stochastic gradient descent. So if we recall the gradient descent, we derived this formula, right? W new is equal to W old minus eta times derivative of loss function with respect to W, where W is W old, right? So in gradient descent and stochastic gradient descent, this formula would be same for updating of weights. But the difference is how frequently they are updating of weights. Okay. So let's see. In gradient descent, what we are doing, let's say we have 100 samples, right? So in gradient descent, we will go through each and every 100 samples, right? And then calculate the loss, right? Loss for 100 samples and take the average of that, and after getting the average of loss function we will update our weights, right? Right. So for one update or one weight update, gradient descent needs to process all training data points, in our case 100, right? But what stochastic gradient descent do? So let's say I have 100 samples, same this scenario. But in stochastic gradient descent, we will process one sample at a time, right? Let's say I have randomly selected one sample and based on that loss value, I am updating a weight. Alright. So this is a major difference between stochastic gradient descent and gradient descent. We are using all training points to update a weight once in gradient descent. But in stochastic gradient descent, we will use one sample at a time and will update our weight according to that sample's loss value, right? Okay. So let's understand the difference between gradient and stochastic gradient descent in detail. Okay. So here first difference is the gradient descent is used training data set, all training data set at a time to compute the gradient, right? We had seen that. And stochastic gradient descent use only one point at a time to compute a gradient or update the weights, right? So gradient descent it is slower due to processing the entire data set, right? As we see, it will use entire data set to process or update one weight at a time, right? Or all weight vector will be updated once after gradient descent gone through the whole the training point. But in stochastic gradient descent, we are processing only one point at a time and updating the weight, right? So if you see, let me go to previous page. Yeah, let's say we are using this as a loss function where our curve is this, right? So in gradient descent, we will go like this direction. We had processed this, then we will go to this, then here. It's an iterative process, right? Gradient descent. So we are going to iteratively near toward our global minima, right? So here our global minima is there. Then we will slowly move towards this and reach here. This is what will happen in the gradient descent. We are making gradually moves toward our global minima. But in stochastic gradient descent, as we are using only one sample, so our updates would be very noisy, right? So let's say we are starting from the same point and then we reach here, right? And then next point we can reach here, right? Let's say then here, then here, then here, then here, and at the last we reach at the global minima, right? So here you can see in gradient descent we are gradually moving toward the global minima, but in stochastic gradient descent we have very noisy updates because we are updating weights based on the one sample, right? In gradient descent knows how all data set is working. So this is the major difference, and hence we are using more frequent updates. There would be more updates than the gradient descent, but stochastic gradient descent will converge faster, or it will find global minima faster than the gradient descent. It's clear based on because it is using a larger data set or whole training data set for update, right? Okay, let's move to the next. What is here? It is slower. We had seen this, right? It is more accurate because it considers the all the point, right? We had seen that like all update would be gradually moving towards the global minima, and it would be more accurate while we are talking about the updates, right? And the stochastic gradient descent has noisy updates. Okay, for the gradient descent, it can converge local minima or even get stuck if there is a high learning rate, right? Or it can stuck at local minima as well. So what is local minima here? Let's move to the previous slide and see. So in this function, if you see, we have two minima here, right? One minima is here and one minima is here. So this can be your global minima. Let me write it here. Global minima, and this is the local minima, right? So in gradient descent, we are using all training points and we reached here, let's say, right? So when we'll compute the next update, we will stuck here because we are gradually point here. Now if you calculate the tangent or gradient here, it will say go, let's say you are here, right? So it will say this is a zero, so a zero tangent, so you don't have to move any further, right? But our aim is to reach here, but we stuck here. In stochastic gradient descent, what happened? As it moves very noisy updates, right? So let's say we have somehow reached here, but for the next update it would be very noisy, so we can reach to here as well, right? Or we can find the next value here. Then our gradient descent will gradually reach here, right? So this is the difference between stochastic gradient descent and gradient descent. Gradient descent can stuck at the local minima, but stochastic gradient descent has more accurate to not stuck at there, or we can say it can escape easily from the local minima, right? The fifth point is that gradient descent requires the more memory to store entire data set. It's very clear, right? We are using all training points to update weight, so it will require more memory. While stochastic gradient descent is only using one point at a time, so it will require very less memory, right? We can load one point at a time and update our weights accordingly, right? Okay, so these are the some points which are gradient descent versus stochastic gradient descent. But there is one another type of gradient descent which is called as a mini batch gradient descent. Mini batch gradient descent. Okay, so what we are doing in mini batch gradient descent, so instead of using one data point at a time or entire data point at a time, in stochastic gradient descent we use one point, in gradient descent we use entire data point. We are using best of both world. Let's say I will take few sample size. Let's say I have 1000 samples, right? Let's say n is equal to 1000, my all training point is 1000, then I will use only 25 point at a time, and this 25 point will be called as a batch size, right? So we will go through 25 samples and then we will update our weight. So this will be called as a mini batch gradient descent. So sometimes people use stochastic gradient descent or mini batch gradient descent interchangeably, because if you provide batch size equal to 1, then it will be your stochastic gradient descent, right? And if you are using any number then 1, then it will be considered as a mini batch gradient descent, right? Yeah, so that's all about today's video. So if you like this video, please subscribe my channel and share it with your friends so they can understand what is the difference between gradient descent and stochastic gradient descent. Thank you.